Consider the power series, the sum from 1 to infinity of 3x minus 2 raised to the n power over n. For what values of x does the series converge absolutely? For what values of x does the series converge conditionally? And then we're asked, what is the radius of convergence? Well, to start off, to find an interval where this converges absolutely, I'm going to choose to use the ratio test. So, I need to look at the limit as n approaches infinity of the n plus first term in absolute value over the nth term in absolute value. So I have the limit as n approaches infinity, and I'm going to write down the n plus first term. So replacing the n's with n plus 1's and putting the variable expression in absolute value. Now I'm supposed to divide by the nth term. To save some space and to work as efficiently as possible, instead I want to multiply by the reciprocal. So n over, and the variable expression in absolute value raised to the nth power. Multiplying by a reciprocal, of course, the same as dividing by something. Very quickly here, I see some things cancel off. I have 3x minus 2 in absolute value raised to the n plus first, divided by 3x minus 2 raised to the n. So there's one more on the top than there is on the bottom, so I can reduce that. Times n on the top over n plus 1. Well, in terms of this limit, 3x minus 2 in absolute value is a constant. N over n plus 1 is going to 1 as n goes to infinity. And so this just goes to the absolute value of 3x minus 2. That is my value of rho here in the ratio test. And so I just need to set rho to be less than 1. Because I know in the ratio test when rho is less than 1, that is where my series will converge. Absolutely. Let's get x by itself. Now I can add 2 to all three parts. And I have 1 is less than 3x is less than 3. And now divide everything by 3. And 1/3 is less than x is less than 1. There is the interval on which my series converges absolutely. We converge absolutely on the interval between 1/3 and 1. In part B, we're asked for what values does the series converge conditionally. Well, that means I need to check the endpoints. Those are the only two places where I might converge conditionally. I know outside of this interval, my series will diverge. So I need to plug in x equals 1/3 into the series and x equals 1 into the series and see what happens. So here's my power series. And I'm curious what happens when x is 1/3 and when x is equal to 1. Well, when I plug a 1/3 in there, I get a familiar series. Minus 1 to the n over n. This is the alternating harmonic series, which we know converges conditionally. If we didn't know that, we could use the alternating series test or one of our other tests to converge it. For this one, the alternating series test is the best way to go. When I plug in a 1, well, if I plug in a 1, I get a 1 to the n on top. That's just a 1, and on the bottom, I still have that n. This is the harmonic series. And we know the harmonic series diverges. So in part B, for what values of x does the series converge conditionally? Well, I only have to report that as x equals 1/3. Now, I'm going to sneak an extra statement in here that now I have an interval of convergence. That I could write my series converges from 1/3 all the way to 1, including the 1/3 but not the 1, because of the work we did back here. Then I have absolute convergence on the inside of the interval and conditional convergence just at that one endpoint. And then that last part, we're asked for a radius of convergence. Well, I know my power series is supposed to have a center, and if I just think about what's between 1/3 and 1, I know that this power series is centered at 2/3. And if I think about the distance between 2/3 and 1/3 or 2/3 and 1, I would know that the radius of convergence that we typically use big R to represent must be 1/3. All right, well, I have a feeling some people watching this video might say, shouldn't I see my center? Right, a power series is supposed to have this form. Some coefficient, right, a sub n, right, some formula for the coefficients times x minus a to the n. And when I look at this, it doesn't really have that format, right? It's not looking like a power series right now. I could write the 1 over n out front like it was a nth term formula for some coefficient, but this is still not an x minus a. So this is a very, I'm very suspicious of this equal sign. Well, let's see what happens if I just do a little bit of work here. Or I could imagine factoring out a 3 on the inside here. All right, and I think I see what's going on, right? I have two things in that set of parentheses raised to the n, so I could raise them both to the n. So this is a 3 to the n. So I'm going to rewrite a 3 to the n over n out front, and an x minus 2/3 to the n. And now that really is written like a power series would be written, and in fact, I see the center really is 2/3. Well, we've accomplished everything we set out to do in this problem, and one extra thing, rewriting this so it looked like it would match the definition of a power series. So that's it for now.